All right, in today's lesson, we're going to be talking about 1.5, polynomials. This is a pretty brief on the stuff that's inside the section. The biggest thing is when we say standard form. Standard form of polynomial is from descending order. So it's written out as this in your textbook. Basically, all these little a's are just different coefficients. They can be the same number, but they are not the same, like connected numbers. But the big thing to pay attention to is whatever the highest exponent is, it will go first, and then in descending order from there. So, for example, I would have an x cubed, and then I would have x squared, and then I had an x, and then I would have some constant number. If there was an x fourth, same concept, but it's in descending order. The other thing is these n's must be a natural number, right? So that will be your, actually, more or less a whole number because it can be zero as well. The way they describe it is a non-negative integer, right? So non-negative integer would be zero and on. So pretty much I just see it as it has to be an whole number. So it has to be 0, 1, 2, 3, or 4. It can't be like fractions. It can't be negatives. It can't be decimals. As long as n is in the whole number family, then it's considered to be a polynomial. The other thing that they talk about is different ways to express things. If you see something in the form of a minus b times a plus b, meaning you're multiplying the exact same first term and last term, but they just have different subtraction addition in the middle, the answer is automatically just going to be the square of the a minus the square of the b term. And then save yourself some foiling. Same concept. If you have a binomial that's being squared, the answer is automatically going to be a squared plus 2ab plus b squared. So if you have it like this, you can just use the formula rather than having to FOIL it out. FOIL always works with these binomials, so you can do it that way as well. A minus b is the same concept. So this will just be a squared minus 2ab plus b squared. The way I remember this for these guys, well, it's just the minus and the plus. Other than that, this is always going to be positive. We have a different saying that we can use for cubes, but we're not quite there yet. All right, so I kind of want to just jump into some example problems so you have plenty to work with. I will say the book is a lot harder than your homework, so I want to make up some different problems that kind of go more with the homework than what the book kind of provides. All right, for starters, I want to start with number 1 on page 58, and it states 3x to the 3 halves minus 2x. So all you got to do here is just determine if it is a polynomial, yes or no. And if it's a yes, determine the degree and the size of the term. So here I look at it, I'm just going to pay attention to the exponents. So I have a 3 halves and there's like an imaginary 1 there. So that's a whole number, but 3 halves is not. So right off the bat, I can say this is not a polynomial. And if it's not a polynomial, then it has no degree to go with. So let's look at number 2. We got 17x squared y to the 5th plus 2z cubed minus 4. When you're dealing with multiple letters with exponents, you just have to add them up with inside the term. We talked about terms and coefficients and factors and constants in the last section. So this right here actually totals up to 7. Then we have just a 3. So those are both whole numbers. So this is a polynomial. It has a degree of 7. So the degree will be whatever the highest exponent is, added together within that term. And then to do the terms, there is 1, 2, 3 terms. Remember, terms are separated by addition and subtraction. So 3 terms means it's called a trinomial. All right. If it was 2 terms, it is considered a binomial. And if it's 1 term, is considered to be a monomial. If it's anything greater than 4 or more, we just simply say polynomial of 4 terms, or whatever the terms are. So if it was 5, then it would be 5. If 6, it would be 6 terms. We don't got any fancy names after that. Let's look at another one. So let's look at number 5. Number 5 is just simply 8. So 8 technically has an exponent. Technically, you can write an x to the 0 power, indicating that there's 0 of them. But that right there, remember, we know is 1. So I'm not changing the value of this expression. We're just kind of seeing what's going on here. And 0 is a whole number. So this would be a polynomial. That's why I like that term whole number rather than just a non-negative integer. Because then you know it's counting numbers plus the 0. So it is a polynomial. It would be degree 0. And there's only one term, so this will be considered a monomial. All right, I'm going to try to fit this last one here. Let's look at number 10. This is 3n to the 4th, m to the negative 3, plus n to the 2nd, m. Now on this one, since 4 and negative 3 do add up to 1, that does not make it a polynomial. The fact that there is a negative causes this to go away. However, had these been the same letter, then we could have simplified it down to just a 1. So since this is a negative right here, this would be not a polynomial. All right, so that's kind of the first set there. Let's look at a different set of problems. Let's look at number 15. 15 says 4s to the 3rd minus 10s to the 5th plus 2s to the 6th. All right, so it says write each of the following polynomials in descending order and identify the degree of the polynomial and the leading coefficient. All right, so we have hold on. So get in descending order. So you start off with the highest exponent, which is 6 here. So that's 2s to the 6th power. The next one would be 5. So the sign will go with the number, and the number goes with the term. This would be minus 10s to the 5th. And then we finish off with a positive. So we write a plus sign for s cubed. So this is in the correct descending order. The degree of this would be 6. And the leading coefficient is what it wants. So the leading coefficient is just the coefficient in front of the highest exponent. So in this case, the 2. All right, so let's look at a different type of problem. Let's look at number 24. 24, you're given 5x. I know that looks like a 9. Let's try to clean that up. So you're given 5x squared minus 6x plus 2 minus 4 minus 6x minus 3x squared. And you're asked to either add or subtract. This is the way I teach it. I think it's the easiest way to comprehend. There might be other ways as well. Textbook probably uses different ways. Some teachers will distribute the negative. I find that when a student distributes, they keep the minus sign for some reason, or it's now became a multiplication problem. So what I do is from the minus sign to the right, I'm just going to change the sign of everything. So this minus sign is now positive. This positive 4 is now a negative. This negative 6x is now positive. This negative 3x squared is now positive. And basically what we just did is distribute the negative, but you kept it all together. So this minus didn't drop down and you didn't start multiplying. After this point, you just combine like terms from highest degree to lowest degree. So I have a 5x squared plus 3x squared. So that would give you, so the way we add is we just add their coefficients. So 5 plus 3 gives me 8. And then the x squared will stay x squared. The only time the exponents change is when you're multiplying. When we're just combining like terms, the x and the exponent remain the same. So then I'm going to take the negative 6x plus positive 6x, and that actually cancels themselves out. So I'm not going to write an x. A lot of students here will write an x. If you do that, you're indicating that the answer was 1, even though we know negative 6 plus 6 is 0. So therefore, do not write an x if they cancel each other out. And then the last one is 2 plus negative 4, and that will give you a negative 2. There you go. Do realize had you got a positive result, make sure you write a plus sign. That's another big mistake students make. And that's pretty much it on that side. So on this one, again, this is where the textbook makes it way harder than the problems that you'll actually see on the homework and on the test. So I'm going to kind of make my own here. So the first one I want to make up here is 4x squared minus 3x minus 4 times negative x. So what we're going to do here is we're going to take this negative x here, and we're just going to multiply to everything inside. So negative x times 4x squared. So that would basically be 4 times a negative, which will make it a negative 4. X squared times x. Remember, when you're multiplying, you're adding their exponent. So that now becomes x cubed. Negative 3 times a negative makes a positive 3. So I'm going to write a plus sign. There's like an imaginary one here. So x times x will be like x squared. Negative 4 times that negative makes it a positive 4. And since there's no x there, I now just have a single x. And that's how you would do a problem like that. I want to do this again, but this time I want to write it as a positive x. And it doesn't matter which side, you're still going to distribute. So again, all the coefficients this time would remain the same. And I'm just going to, when I multiply, add 1 exponent to each x. So this becomes x to the third minus 3x to the second. And again, because this doesn't have an x, this just becomes minus 4x. The next type I want to look at is one like this: x plus 2, x plus 7, right? So when we FOIL, you just do first. So that's the F part. So first, x times x gives me x squared. Then we do the outside. This is the O part. So that's going to be x times 7. So that's going to be 7x. Then I'm going to do the 2 times x. That's the inside part. So 2 times x gives me 2x. And then I'm going to do 2 times 7. That's the last part. So there's the FOIL right there. So 2 times 7 gives me 14. The only things you can combine are the ones in the middle. So 2 plus 7 gives me 9x plus 14. And that would be it on that one. All right, let me do another one. Let's do kind of similar, but x minus 2 times x plus 7. Same process. X times x gives me x squared. X times 7 gives me 7x. Negative 2 times x gives me negative 2x. And negative 2 times 7 gives me negative 14. I combine the middle one, so it gives me x squared. 7 minus 2 gives me positive 5x. Notice the x didn't disappear. The x is still there, and it didn't become an x squared either. So there's your answer right there. One more that I made up. This one is 4x plus 5 times x plus 4. All right, same process. I'm going to do the first. So this time it's 4x times x. So just like up here, that would give me 4x squared. The 4 remain the same, and then x times x is x squared. Then I'm going to do 4x times 4, and that would give me positive 16x. So this time, I can multiply the 4s, and then the x rides on. Then I do 5 times x, and that does give me 5x. And then I do 5 times 4, and that gives me 20. I'll still combine my two middle terms. So I get 4x squared plus 21x plus 20. All right. The rest of them, I agree with what's in the book. So let's do those. So let's start back up on number 33. This would be 6x minus 3y times x plus 6y. So even with multiple letters, you can still distribute the same way. 6x times x would give you 6x squared. 6x times 6y would still multiply the sixes, so that'd give me 36. And then when you have multiple letters, it is standard to do alphabetical order. So x times y would be xy. Negative 3y times x would give me negative 3, and then xy to do an alphabetical order. And then negative 3 times 6 gives me negative 18 y squared, since I actually have two y's being multiplied. If things can be combined, they don't always get to be combined, but if they can, it's going to be the middle terms again. So 36xy minus 3xy would just give me 33xy. So again, I just combined the coefficients and the xy term remains the same. All right, let's look at another one. Let's look at number 37. 37 is 6xy squared minus 3x plus 4y times x squared y plus 6xy. All right, same process in this one. You can take each one of these and distribute, or you can take each one of these and distribute. It doesn't matter. I usually move left to right, but again, it doesn't matter. So I'm going to take the first term and I'm going to multiply to each one of these terms. So 6xy squared times x squared y. Any coefficients I'll multiply. So 6 times imaginary 1 gives me a 6. X times x squared gives me x cubed. Y squared times y gives me y cubed. Then I'm going to do the same thing to the next term. 6 times 6 gives me 36. X times x gives me x squared. Y squared times y gives me y cubed. Notice I'm multiplying each term, but I'm kind of separating them out within their factors. All right, then you do the same thing with the next set. So negative 3x times x squared y. So that'd give you negative 3x cubed y. And then negative 3x times 6xy would give you negative 18. X, again, there's two of them, so that'd be x squared and then just a y. Last part now, I'm going to do this last term to them. So 4y times x squared y would give you a positive 4. I don't know why I have so many marks here. Yep. All right, so that gives you positive 4 x squared y squared. And then this gives you 4y times 6xy. So that'd be 4 times 6, which is 24. X, y squared. And by keeping it in alphabetical order, you can easily see if there's anything that can be combined. And I don't necessarily see anything that can. And that one's let's see. So we got x cubed. So this one gets a little interesting. Typically, the way we would write this is the highest exponent to the lowest exponent for the most alphabetical order. And the y would just be pretty much just attached with it. So like for instance, and you would go by like highest degree and combine. So when we rewrite this in the correct order, this has 6 as an exponent. If you combine those, this would be 6x cubed y cubed. And then this would be 36x squared y cubed. And then you would want to do, so this has 4, this has 3, this has 4, this has 3. To really be honest with you, I don't think it matters because it goes 4 of 3. So all I'm going to do is I'm just going to write it. Uh, you know, I don't think it matters. Like if they mark it wrong, please let me know. But in this way, it's really hard to tell which one can be the highest and lowest due to the fact that there's so many different ones. So it should just accept it as is like that. Nothing to combine there. But if you do get some issues, let me know and we'll definitely analyze it a little bit more. My first instinct, like I said, is to go to highest degree, but then we have all these fours and threes. So maybe you want to put the fours together. So maybe rewrite it with x cubed y and x squared y squared before writing the other two. But I honestly don't think it matters. It shouldn't matter. But if the online part does give y'all some issues, reach out to me and we can definitely reevaluate this. All right. One more problem, or not one more problem, one more set. Let's look at number 39. We have 3a plus b squared. Same concept. They just want you to use the special products. So remember, this is where we're going to use the a plus b squared gives us a squared plus 2ab plus b squared. So what that means is I'm going to take the first term and I'm going to square it. So 3a squared would be 9a squared because the square would be applied both to the 3 and the a, plus it looks like 2 times a and b. So 3a times b would give me 3ab, and then 2 times that would give me 6ab. That's kind of how I did that. Multiplied it and then multiplied by 2, and I got that middle term. And then the b term squared would just be b squared. So I instantly got my answer without having to fold it out. So those are some of those specials. All right, last one. X minus 5y squared. Again, this is going to use that concept of a minus b squared equals a squared minus 2ab plus b squared. So again, I'm going to square the first term. So x squared is x squared. And then I'm going to multiply these two guys. So x times 5y is negative 5y, negative 5xy. And then I'll multiply that by 2. So that gives me minus 10xy. And then I'll take the negative 5y squared, and that would give me a positive 25, because negative 5 times negative 5 is positive 25, y squared. If you do forget the trick in the middle of the test or something like that, the full method works just as good. You would just rewrite these out as 3a plus b times 3a plus b. Or same concept here, you would say x minus 5y times x minus 5y if you need to. Other than that, that's pretty much it in 1.5. Pretty quick and easy. However, if you need more examples or if that 37 type of problem doesn't work out in your homework, let me know. Other than that is all I got for this video. Until the next one, bye for now.